Greeting everyone. So, as you know, we were uploading videos on current electricity and all. So, what we have decided here that we will also upload some hot question or some popular thinking based question. In that video segment, what we will do, what is that we will discuss a particular question in which it is very hard to understand what is actually happening. So what we have arranged here is I'll explain you first theory part, then actually I'll show you what whatever we are studying, how it actually looks in the practical life. Just like earlier, we have uploaded one segment also. So from now onwards, we will also upload video segment like this, in which we will talk about some concepts, some topics, in which we will talk about the theory and the live practical segment, and the regular segment is also going to happen. So what we are going to discuss here is, it is a question in which you have a system which is in static equilibrium, but if you cut this string or cut this spring, what happens to the things or the boxes which is tied to the string? So here, first we will discuss basic one, in which we will have a pulley or you can also take it without pulley, because pulley might make you a little bit confused. So here is a string and one mass is attached to a string, and we can have another mass also attached to a string, and lastly one more. Okay, so here the question is, let's say this is A, it is 5 kg, it is 10 kg, it is 20 kg, right? Finding tension is not a big deal for anyone, I guess, right? And there are 3 points on the string, that is, you have B, E and F. Okay, so what is the question that if you cut this string at any particular point C, D or F, what you have to figure out, what is the new tensions, and also what you have to figure out, what is the acceleration of individual boxes. So here I will ask you one question. If system is in static equilibrium and string from point E is cutted, find acceleration of each box at the same instant. And new tension, right? So in this type of question, what you need to do is, first you have to draw the FBD for the system when it is in static equilibrium, means before cutting the string or spring. Then you have to draw the FBD when you actually cut the string or spring, and then you will get the answer. So I'll let you think what will be the answer, and then I'll tell you the answer. First, be honest and try. It is very fairly simple, so I don't think you should be getting any confusion with that. So try. Okay. How would you do it? First, before cutting, right? Before cutting, FBD you will draw, and you know the tension you draw always away from the body. So it is T1, it is T2, it is T2, it is T3, it is T3, right? And if you draw the FBD for individual, right, system is in static, so T1 is T2 and there is a 5G, and similarly you will draw for T2 and there is a force T3 and 10G, and there is a T3, so it is 20G. And if you figure it out, you will get to know that T3 is 200, we are taking GS10, T2 is 300, and T1 is 35G or 350 Newton, right? Each one is in Newton, right? So it is before cutting, then we'll talk about after cutting. Okay. So when you cut this string, very important thing you have to know is the moment you cut this string, the moment you cut this string, tension becomes 0. Okay. What else also we are assuming? That the string is non-stretchable, right? In real life, whatever string you will use, it is going to stretch, and the string will also have some mass. So what we are assuming, there is no mass of string and there is no elasticity in the string. So the moment you will cut from E, tension will become in that string. So T2 will become 0. Got it? And the other system will fall in the influence of gravity. That means their acceleration is going to be G. In reality, if also we are going to show you the experiment, but in reality, if you are going to see what actually we'll see, if I cut from this point, of course they will freely fall. Means their acceleration will be G, both B and C. But what else you will also see, that A will slightly move upward with little bit of acceleration. But when we are discussing theory, we will say it is not going to move. Why? That just because the simple reason is, just earlier I said, what we are assuming, there is no elasticity of string and there is no mass of string. In reality, the string will get little bit of, it will stretch a little bit, and as soon as you cut from this point, the total tension will decrease, and then because of its elasticity, it will pull 5 kg a little bit up. So it will move slightly up, but in theory we will not discuss that part, because just I have said that the elasticity and mass of string is not in the case. So after cutting FBD, if you draw, after cutting, if you draw the FBD, now the new tension, we will call it, this is the box, this is the string, right? So the new tension, we will not call it T1, we will call it T1 dash. Got it? And the other two masses will freely fall. So, if you solve this question, this is how you have to solve. The point from where you are cutting the string, take the tension to be 0, and from there onwards, the system will fall freely. The system will fall freely. Correct? And if it is falling freely, what else you will see, the tension here we will call it T3 dash, right? It is also going to be 0. I'll show you. It is also going to be 0. And if you calculate T1 dash, it will come out to be 5G. And how so T3 dash is 0? Because if you see the FBD of 10 kg, the moment you cut this string, the force is 10G. And the new tension we are calling it T3 dash. Same you will draw for 20, right? So it has a tension upward, so we'll call it T3 dash. You can see here also 20G, and we know their acceleration is going to be what? G. So in that case, if the acceleration is G, so 10G plus T3 dash must be equals to what? 10G. That means T3 dash should be 0. Same we can do for that also. That means the tension in between this box will also be 0. So the only tension you will see in that box, and it will also decrease. So the moment you will cut, the acceleration of B and C will be equals to G, but this will be 0. We can also verify T1 dash is 5G, downward is also 5G, then it means it is in static equilibrium. So in theory part, just remember whenever you have this question, just remember that from wherever you are cutting the string, remember what is string, the tension will become 0 and the system down of that cutting point will fall free and the upward thing will be in static, and you can simply solve this question, not a big deal. Got it? Fairly simple question, right? So another one I will give you as a homework, and then I will talk about the another question. Got it? Okay, one more thing I will again add up, that if you, when you will see the video, it will not be 0, it will be upward with some non-zero value. It is only due to that string will have some elasticity, and I have said we will not take elasticity of the string. Okay. Now another question we will talk about. This question I will give you as a homework. You can try. So this question is your homework question, and you can do this question with no problem, and even if you are not able to solve, we will come back and discuss this question. So there is no problem if you are not able to do it, but what I wish to see is you trying to do this question. You might think, sir, oh, you are giving us movable pulley and you solve that question. Don't worry, I will solve that question also if you are not able to solve it. But if you are able to solve it, then it means you understood everything. So this is the question. It is 40 kg, it is 20 kg, it is 60 kg, it is 50 kg. Right? The points are A and B. So you have to find if one more thing I'll add to make it. Okay, so this is the question, you can try, and next we will discuss right with another question of spring. Okay, so you can take a screenshot and you can try. Okay, so another question we will discuss where we are not cutting the string, or again we are cutting the string, but we'll take the spring also in the system. Okay, in that also I will give you one homework. Duplicate. Duplicate. So here is another arrangement. It is little different from the earlier question, but still it is solvable. Just little bit of intuitive thinking you need to have. Right? So this is your box A, B, C, and D. Initially system is in static equilibrium, right? And there are points. This is the point E, F, E, F, and we will take another point as G also. So this is the question. This is your point E, F, and G. Got it? So the question is simple. If initially system is at rest, find the acceleration of each box when string snaps suddenly from point E, and second you have G. So this is the question. First you think what will be the acceleration if you cut this string from point T. I'll let you think, and then you have to think what will be the acceleration when you cut it from G. What will be the acceleration of the box when you cut it. For this also we will show you the experiment, and but first we will talk about the theory part, then we will see the experiment. So I wish that you are going to try, and then you can come up with your answer. Whether it's correct or wrong, it is not the issue. But if you are trying the question, then it is well and good. Okay, you try. Okay, I'll show you. First, if you cut it from E, but wherever you are, whatever you are doing, first you have to do the FBD before cutting stage. Before cutting. So if you are talking about before cutting things, and remember, unlike spring force will only be 0 when the change in length will be 0 in spring. Spring force will be suddenly 0 the moment you cut it, but spring force can't be 0 at the exact moment. It will only be 0 when the spring will attain its natural length. So first let's see the FBD. Then we will see how we will do it. So this is your T1, this will be your T2, and here is your Fs, here is also Fs, and here is your T3 and T3. Got it? And if you draw the FBD for each one, you can see T1 and downward T2 also you have 20 G, right? And then you have T2, then you have Fs, then you have 30 G, right? And then you have Fs, then you have T3, then you have 40 G, and lastly you have T3 and you have 50 G. And if you write the equations, what you will see before cutting stage, T3 you can see it is your 500 Newton. Fs, if you see, Fs will be your 900, and if you see T2, T2 will be your 1200, 12, right? Okay, and T1 will be your 1400. You can calculate it from that equation also. Okay, so this is the IBD before cutting stage. And if you talk about after cutting, what we are doing from first, we are doing first part, means when we are cutting from E point, what you will see the moment you will cut, I said the moment you will cut, T3 will become 0. That we already know, tension will become 0. But what will happen to Fs and all? See, I told you spring force cannot be 0 until the spring attains its natural length, right? So spring force is only 0 when change in length is 0, because the formula is F delta x, F is equal to K delta x, right? So that means here, if you see, if I draw if I take this picture and if we check it, right? So this is the box. Okay, so this is the picture, and the moment you will cut, what will happen? We know string will get loose, right? string will get loose, tension will become 0. So right, you can see the box A, right? It is falling with G, right? Tension is 0, no problem with that. But what here you will see the different thing. Fs is not 0 because spring is already stretched. Right? Fs will also slowly decay, but the moment you will cut, it will have some value. So if you see, Fs was earlier how much? 900. If you see the FBD for B, Fs will not be 0. We are talking about just after cutting. Remember, just after cutting. Just after cutting. Fs will also decay, but just after cutting, Fs will be your what? 900, and there was another force 400, and you can see 900 is bigger than 400 already. It is obvious, you can see, and mass of B was 40 kg. So that means it will move upward, and if you see 900 minus 400 equals to 40 into A, what you will see is the acceleration will come out to be 12.5 meter per second upward. Yes, that is correct. The moment you will cut it, this will not be stationary, it is going to move upward with some acceleration which we already have calculated, and it will move as it will move this and again this Fs will also not be 0 the moment you have cut. This body will slowly move upward, not slowly actually, it will move upward, and then Fs will be 0. In reality, it will start oscillating. First it will go up and then it will start oscillating. So T1, T2 will also change. But the moment you will cut, T1, T2 will not change. T1, T2 will not change. But as it will move gradually upward, then it will start oscillating, and then each and every one value will be a function of time. That will be a damped oscillation that we are not going to discuss in that segment. But what I am saying, we will see that video also. If you cut it from that point, the moment you cut, it will move upward, and the system will stay stationary, and it will move upward. Maybe it will go and hit the 30 kg, and then it will start oscillating, or maybe it will just go just near to 30 kg, then it will start, it will fall back, and then it will start oscillating. So when you do spring question, what you have to understand is that the spring force cannot be 0 the moment you will cut. It will be 0 only when the change in length will be 0. Got it? And the last part for this question we will discuss here. In that part, the string has been cut from G. This is very interesting part. Very interesting part. If you cut from this point G, again we are cutting from G, right? We are cutting from G. So this string is broken. So here T will become different. It will be T dash, and it will be equals to 200 Newton. But the interesting thing you will see in this question, first I will tell you what we are going to get the answer. The moment you will cut this string, this whole system will stay still in the air, and this system will come down until the spring attains its natural length. This whole system will be stationary, and only thing which will be moving is 30 kg. Right? It is just opposite to the previous case, and you will see that proof also in the video also. First we will see how mathematically I am going to justify it. So T dash, I am guessing that T1 dash is not confusing anyone. That is fine. But again, Fs will not be 0 just after cutting. Just after cutting, Fs will not be 0. So if you draw the FBD, Because Fs is not 0, so you can see Fs for B is upward and T3 is downward, and there is a 40 kg force, 40 G. What was the Fs? 900. Fs is your 900 and T3 is your 500, and you can see both forces are cancelling out each other, and the acceleration of B, that means, will be 0, just what I have said. And if you talk about the other one, for A, it is T3 and here it is 50G, and again T3 you can see it was 500. That means acceleration of A will be also 0, right? But if you see the acceleration of C or the ability of C, there is no tension to support it, but there is only Fs downward. Also there is 30 G downward, right? So both forces are downward, that means acceleration will be also downward, right? So acceleration will be just your what? Fs is your what? 900, 1200 and over what? 30, and you can see it will be 40 meter per second downward, right? And this is what I am saying. When you will see the video also, what you will see, the moment I will cut this string, this whole system will stay still in air. Stay still in air. Yes, even though you have cut it from that point, this whole system will stay still in air, and this only will move downward with some acceleration. Got it? Until Fs becomes 0. Until Fs becomes 0. Got it? This is very interesting, that the whole system is staying still, and that this whole system is staying still, and the only thing is moving is upward. You will see you will feel like it is some sort of editing also, but it is what going to happen, right? So these are the questions we had to discuss today. And what question I will give you as homework also. In the same question, you have to find, if not string, if the spring snaps from point F, you have to find acceleration of each and every body. For this also we will upload the video, but for this I am not going to talk about the theory part. I'll let you do, and in next video we'll discuss the theory part also.
Yes, sir. Yes.